Welcome back, Rustaceans! Ready to unlock the secrets of variables in Rust? In this episode of Rust Run, we're diving into 4 super important concepts every Rustacean needs to master: variables, mutability, constants, shadowing. Just like we saw in the guessing game, variables in Rust are immutable by default. This is one of Rust's ways of helping you write safe and predictable code. However, you still have the option to make your variables mutable. Let's see how Rust encourages immutability and when it's okay to go flexible. Let's start by creating a new Rust project called variables. I'll use the cargo new command followed by the project name. Now navigate to your project folder and open it in VS Code. Let's create a simple example to see how our program behaves if we try to assign a new value to an immutable variable. We've just created an immutable variable called x and assigned the value 5 to it. Now we're printing its value to the screen. Notice that in this example, we're using another variation of the println macro. Rust lets us format output by placing variables inside curly brackets, which are replaced with their values when printed. Now let's go ahead and try changing the value of x. Even before we compile the code, one of the extensions from the Rust Run extension pack detected the error. But let's go ahead and run the program to see what happens anyway. Let's run our project using the cargo run command. This example shows how the Rust compiler helps catch bugs early. When we try to change an immutable variable, we get a compile time error. And that's actually a good thing. It means we can catch mistakes before the code even runs. The best part, Rust's documentation is super detailed, so it's easy to figure out what went wrong and how to fix it. We can also use the Rust explain command for a more detailed explanation of what went wrong. It breaks down the error in plain language and often suggests how to fix it. Super helpful when you're learning. As we can see, the documentation suggests 2 ways to fix the issue. Either create a new variable or simply add mute to make it mutable. Let's go with the second option and make our variable mutable by adding mute between the let keyword and the variable name. This explicitly tells Rust that the variable's value is allowed to change. In Rust, immutability by default is a deliberate design choice. It promotes safe, predictable code by preventing accidental changes to data. This makes it easier to reason about your program's behavior and avoid subtle bugs, especially in concurrent or complex systems. When you do need a variable to change, adding mute makes your intention clear both to the compiler and to other developers reading your code. It's all about writing code that's easier to understand, maintain, and trust. Like immutable variables, constants are values that are bound to a name and are not allowed to change. But there are a few differences between constants and variables. Here we've declared a constant called max_score with a value of 100. This might represent the highest number of points a player can earn in a game. There are a few things to note. Constants are declared using the const keyword. The name follows Rust's naming convention for constants, all uppercase with underscores. You must specify the data type when declaring a constant. We'll explore data types more in the next video. But let's quickly see what happens if we try to declare a constant without a type. Right away, the IDE underlines it with an error. That's because constants always need to have a known and fixed type, so the compiler can evaluate them safely at compile time. Rust doesn't allow mute with constants. They are always immutable by design. If we try this, the compiler will throw an error. Now, let's try assign a new value to our constant and see how the compiler reacts. As expected, Rust doesn't allow this. The compiler will immediately notify us that we can't assign a new value to a constant because constants are always fixed and unchangeable. Now, let's add a line that prints our constant to the screen. But before we run the program, let's take a look at one more example. Let's declare another constant, but this time we'll place it in the global scope. This constant represents the number of seconds in 3 hours. Since the calculation uses only simple numbers and operators, Rust can fully evaluate it at compile time, making it valid for a constant. Constants can be declared in any scope, including the global one. This makes them especially useful for values that your entire program or even multiple files might need to access. In future videos, we'll talk about how Rust code is organized into modules and crates, and how constants declared in global scope can be accessed across files and modules. For now, just know that constants like 3 hours in seconds can act as shared, readable, and safe values throughout your code base. Now let's print our global constant to the console and run the application to see the result. We can see that both values are successfully printed to the console, and the compile time calculation for 3 hours in seconds works exactly as expected, demonstrating how constants are evaluated during compilation and ready to use at runtime. Now it's time to cover a powerful Rust feature called shadowing. You actually saw it in action in the guessing game, but now let's break it down and see how it really works. Let's walk through this short example to understand how shadowing works in Rust. We start by declaring a variable x and assigning it the value 5. Then we declare x once again using the let keyword. This creates a new variable with the same name and assigns it the result of x plus 1, which is 6. Since we used let again, this isn't a reassignment, it's shadowing. When we use println to print the value of x, Rust uses the most recent version, so the output will be the value of x is 6. Now, let's take our shadowing example a step further by introducing an inner scope. So let's go ahead and create that. I'll open up a new set of curly braces right here. An inner scope in Rust is just a block of code wrapped in curly braces, like this. It creates a separate temporary environment where we can define new variables or even shadow variables that were declared outside the block. Inside this scope, I'm going to shadow x again and multiply it by 2. So in this block, x will have the value 12, while the original x outside the block stays unchanged. Let's print the value of x here, and we should see the value of x in the inner scope is 12. All right, let's run the program and check the output. The value of x inside the inner scope was 12, and outside the scope it goes back to 6. That's because the x declared inside the block was temporary. It disappeared as soon as the scope closed. This is a great example of how shadowing works hand in hand with Rust's scoping rules. We'll talk more about scope and ownership in future videos. Let's take a look at another cool difference between shadowing and mutability. This one's especially interesting. With shadowing, we can even change the type of a variable. Here, we start with the spaces variable as a string, just a few blank characters. Then, on the next line, we shadow it by using let again and assigning spaces, len. This function returns an integer representing the length of the string. Now the spaces variable becomes a number, in this case 5. And that works perfectly because shadowing allows us to redefine a variable with a completely new type while reusing the same name. But if we try to do the same thing using mute instead of shadowing, we'll get a compile time error. Rust doesn't allow changing the type of a variable, even if it's mutable. In this video, we wrapped up some core Rust concepts: variables, mutability, constants, and shadowing, and even got a sneak peek at scopes. You're building a solid foundation, and we're just getting started. In the next video, we'll dive into one of the most important parts of any programming language: data types. Can't wait to see you there. If you're enjoying this Rust journey, don't forget to subscribe to the channel so you don't miss the next episodes. Hit that subscribe button, give it a thumbs up, and let's keep learning Rust together.